is October 22nd. We're reviewing for the test tomorrow. This is what you need to know from Chapter 3. If you recall, in Section 3.1, we basically skipped it because that was introducing how to graph systems of linear inequalities. Solve them by graphing. And I had said with graphing, we can't always find an exact solution. So we went on to elimination and substitution. So from Section 3.2, you need to be able to do elimination and substitution. And I say and. I'm not going to make you use one or the other. You use whichever one you're most confident with.
We had a test on that, right?
We already had a test on that. That was our last 50-point test that most of you did really well on. Okay? So just refresh your memory on that. How you do it is going to be a system with 2 equations, 2 unknowns. We will. I want to go over last night's homework, though, because that was difficult. All right? You also need to be able to graph linear inequalities. If you have a note, I need it on my podium.
After 6 hours, Mr. Chambers is left.
And absolute value inequalities. This is not in combination one with another. This is just one by itself. If you remember, linear inequalities, we put it in y mx plus b form. We had either a broken or a solid line, and we shaded either above or below. Okay? Absolute value inequalities. What do those look like? A V. And we had either a solid V or a broken V, and we either shaded above or below. All right, so be able to do those. Oh, that's from section, actually this is an introduction into section 3.3. And then 3.3 dealt with systems of linear inequalities. That's graphing more than one linear inequality on the same graph.
That's what we did 2 nights ago.
That's what we did 2 nights ago. Drawing the arrows and trying to find where they're pointing in towards each other. Okay? You need to be able to do that. There's going to be a lot of graphing.
Yep.
Section 3.3 is all graphing. We skipped section 3.4, and then we have section 3.5, which is the 3 variables. Solving a system of equations with 3 variables. Okay, so you need to be able to do these things right here for the test tomorrow.
That's it?
Yes.
Can you work them out?
Okay. I want to show you, because Quentin was trying to show us yesterday, exactly what we are finding when we're finding a system of equations with 3 variables. Okay? So everybody just pay attention up here. If you look at the homework you had last night, what was the first problem you had to work? Number 13. Okay. What page? Okay. Okay. When we are graphing in 3 dimensions, we're not graphing just a line. We're graphing planes. Okay? Because if it's 3-dimensional, there's an X, there's a Y, and there's a Z. So if you look at the walls, the ceiling, the floor, that's an example of a plane going out in more than just 2 directions. Okay? Number 13. This is the system that we were trying to solve. Here was our first equation. Okay. it's a line. Excuse me, I need to put X. That's why. Okay? Here was our second equation. That's where that one exists. And here was our third. Not B, that would be Y, plus 3Z equals 2. All right, so this is what we're dealing with, okay? This is why I'm not asking you to graph it. And what we're looking for is the one point where all three of these things cross each other. So let's see if we can find it. Tell me when you see it.
I see it.
Do you see it?
Yeah.
It's right there.
There you go.
It's that point right there. That's where all three of those planes intersect each other. Look, there it is again. Y'all see the point? That point is where the three things intersect each other, and that's what we're trying to find. Notice, it's not on just an XY axis. There's a third dimension here. Okay? Now, I know a lot of times in algebra, y'all sit here and go, what am I ever going to use this for? Okay, you personally may not ever use this, but what do you think something like this could be used for?
Carpentry.
Carpentry, architecture? Yes, aggravating Algebra 2 students.
Failing
Teachers.
Teachers.
Teachers are not used.
What about aviation?
Aerodynamics.
Okay.
Mapping.
What about topography?
What is that?
Taking maps and doing the elevation, the sea level, the elevation of mountains and all this other stuff.
Like on a globe, they have that.
Okay. What about in aviation? Let's talk about the military. What about finding your targets?
Ooh, radar.
Okay.
Plotting points.
All right.
Mr. Neely cheated on that. That was the only thing he ever cheated on.
Okay. But this stuff is used. So I just wanted y'all to see exactly what we are doing here. We're not just solving X, Y, and Z. Okay? We're finding stuff. We're finding stuff. This is used in the real world. You personally may not ever use it, but then again, you might. Okay? All right, and I'm sure there's many, many other examples. I just can't think of any right now. James, I can't hear you.
Can I just-
Yes. Okay, now that we've done that, let's go back.
That's what it's-
Starting with 3-2. Three two involves equations, and we are trying to either use elimination or substitution to find the values of two variables. And we are actually looking for a specific point and what's happening at that point. If there's only two variables. We're looking for a point where two lines are intersecting. Okay? Quentin, I need you to be quiet. Suppose I wanted you to solve this system of equations.
We're on 3-5.
3-2 right now. I'm just going to do a couple of examples.
Substitution.
Okay, if I was going to use substitution, the easy